The arrival of 3I Atlas in the Solar System marks a groundbreaking moment in astronomical discovery. This object, first observed in October 2017 by the Atlas Asteroid Terrestrial Impact Last Alert System Survey, is the first confirmed interstellar object ever detected passing through the Solar System. Its discovery is an unprecedented event in space science, as it opens a new chapter in the study of objects that come from beyond our solar neighborhood. While the observation of comets and asteroids within the solar system is common, the detection of 3I Atlas has forced scientists to rethink many of the assumptions they had made about the nature of space, the behavior of interstellar objects, and the forces that shape the universe. 3I Atlas is not the first object from outside the solar system to have passed through, but it is the first to be definitively identified and studied. For centuries, astronomers have speculated about the existence of interstellar objects, with some suggesting that objects like comets or asteroids could potentially travel between stars. However, despite these predictions, no clear evidence had been found until 3I Atlas. Its detection challenges our previous understanding of the solar system as a relatively isolated system, suggesting instead that our Sun and its family of planets are part of a much larger, dynamic cosmic environment. The object's interstellar origin forces us to reconsider how we view our place in the galaxy and the nature of the objects that inhabit it. 3I Atlas is an asteroid-like object, but its origins are not tied to the familiar asteroid belts or distant Kuiper belt objects we know within the solar system. Instead, it comes from a far-off star system having traveled across the galaxy to reach our star. Its speed and trajectory suggest that it is not gravitationally bound to the Sun, but merely passing through the solar system on a hyperbolic trajectory. Unlike objects that orbit the Sun, 3I Atlas is on a path that will eventually carry it beyond the influence of the solar system. It is moving too fast to be captured by the Sun's gravity, and its passage through the inner solar system is a brief, fleeting event. Yet despite its short visit, 3I Atlas's presence is a significant event in the history of astronomy, offering us the first real chance to study an interstellar object up close. The object's name, 3I Atlas, reflects both its discovery and its classification. The 3I indicates that it is the third interstellar object to be observed following the detection of its first and second cousins, and Atlas refers to the survey that first identified it. The name itself is symbolic, representing a new era in our understanding of the cosmos and marking a shift toward a more expansive view of our place in the universe. The detection of 3I Atlas has brought into focus the possibility of many more such objects, many of which could be passing through the solar system without our knowledge, only to remain undetected due to the vastness of space and the limitations of our observational tools. The study of 3I Atlas has opened a new frontier in space research, one that is not confined to our solar system, but instead reaches into the broader galactic community. While it is rare for objects from outside the solar system to pass through our region of space, it is not impossible. With advancements in technology and the increasing number of surveys dedicated to tracking asteroids, comets, and other celestial bodies, it is likely that more interstellar objects will be discovered in the years to come. 3I Atlas may be the first known interstellar object, but it certainly will not be the last. As astronomers continue to monitor 3I Atlas's path, They are not only observing this single object, but are also gathering critical data that will inform our understanding of the broader phenomenon of interstellar space. The object's trajectory, speed, and behavior will provide valuable insights into the physics of objects traveling through interstellar space. The study of interstellar objects is a relatively new field, and much remains unknown about how these objects form, how they move through space, and what forces act upon them. But the study of 3I Atlas is providing us with the tools we need to begin answering these questions and building a more comprehensive understanding of the universe. The discovery of 3I Atlas represents a major milestone for the scientific community, but it also brings with it a host of new questions. How common are interstellar objects? How do they travel between stars, and what are the factors that determine their speed, composition, and behavior? The answers to these questions could revolutionize our understanding of the cosmos and our place in it. 3I Atlas has already changed the way we view the universe, and its study will likely lead to even greater discoveries in the years to come. It is an object that has sparked a reevaluation of many of the assumptions we've held about space. And as we learn more about it, we will continue to redefine the boundaries of our knowledge. The fact that 3I Atlas is an interstellar visitor traveling across vast distances of space also forces us to reconsider the dynamics of our own solar system. The object's entry into the system brings into focus the broader cosmic environment in which our sun exists. The solar system is not a solitary body, but a dynamic component of a much larger galaxy. The passage of interstellar objects through our space is a reminder that we are connected to the greater universe in ways we have only begun to understand. The study of 3I Atlas is just the beginning of a new era in our exploration of interstellar space. This new knowledge challenges the conventional understanding of celestial dynamics, forces us to rethink the origins of cosmic objects, and pushes the boundaries of what we know about the universe. In this context, 3I Atlas serves as a powerful symbol of what lies ahead in the field of space exploration. Its unexpected arrival and the questions it raises will undoubtedly inspire generations of scientists to continue exploring the vast expanse of the galaxy. It is a reminder of the many mysteries that still lie hidden in the universe, waiting for us to uncover them. As we continue to study interstellar objects like 3I Atlas, we will not only learn more about the nature of space itself, but will also move closer to understanding the origins of our own solar system and the forces that govern it. The future of space exploration is bright, and the discovery of 3I Atlas is one of the first steps in our journey to understanding the larger universe that surrounds us. The path of 3I Atlas through the solar system was an unprecedented event for astronomers, marking the first time an interstellar object had been confirmed to pass through the system. However, the discovery of 3I Atlas raised more questions than answers. As scientists began to study the object's trajectory, composition, and behavior, they realized that this was no ordinary comet or asteroid. Its origins in a distant star system, its unusual speed and acceleration, and its lack of typical cometary features made it clear that 3I Atlas was something entirely new. As the object passed through the inner reaches of the solar system, astronomers were forced to rethink many of their assumptions about the behavior of objects from beyond the solar system and the forces that govern their motion. The first clue that 3I Atlas was not a typical solar system object came from its speed. Objects that come from within the solar system generally follow relatively predictable elliptical orbits around the Sun. However, 3I Atlas's path was entirely different. Its high velocity indicated that it was not bound to the Sun's gravity, and instead was merely passing through the solar system on a hyperbolic trajectory. The object's speed was far too high to be captured by the Sun's gravitational pull, meaning that it was a visitor from outside the solar system simply passing through on its way to another part of the galaxy. This marked the first time that astronomers had observed an object traveling at such a high velocity, and it raised important questions about how objects move between stars and what factors influence their trajectories. The object's unusual motion also highlighted a key aspect of interstellar space: it is far from empty. While we often think of interstellar space as a vast empty void, the reality is that it is filled with sparse gas dust and radiation. Objects that travel through this region of space are subjected to forces that are not present within star systems, and these forces can have a significant impact on their motion. 3I Atlas's path through the solar system was influenced by both the gravitational pull of the Sun and the interstellar medium, and understanding how these factors interacted to shape its trajectory became a focal point for scientists studying the object. While the discovery of 3I Atlas was a major achievement in itself, it also provided a rare opportunity to study an object that had traveled across vast distances of space. The object had been journeying through the interstellar medium for millions, if not billions, of years before it encountered the solar system. The fact that it had managed to survive this long without being significantly altered by the harsh conditions of interstellar space was remarkable. The object's structure and composition were key to understanding how interstellar objects can endure the challenges of space travel. Scientists were particularly interested in the object's ability to maintain its integrity, despite being exposed to radiation, cosmic rays, and the sparse particles that make up the interstellar medium. 3I Atlas's lack of a visible tail was one of the most striking features that set it apart from typical comets. Comets, as they approach the Sun, release gas and dust from their icy surfaces, forming a bright coma and tail. This is a well-known feature of comets, but 3I Atlas did not exhibit these characteristics. Instead, the object appeared to be composed primarily of rock or metal, rather than ice and dust. Its surface remained largely unchanged, suggesting that it was far more stable and resilient than the typical comets that are commonly observed in the solar system. The absence of a tail raised important questions about the nature of 3I Atlas and whether it represented a new class of object, entirely one that combined characteristics of both asteroids and comets, or perhaps something else altogether. As the object continued its journey through the inner solar system, astronomers began to investigate possible explanations for its unusual behavior. The acceleration of 3I Atlas, which could not be fully explained by the Sun's gravity, was particularly perplexing. One possibility was that the object was experiencing non-gravitational forces, such as radiation pressure. Radiation pressure occurs when an object absorbs sunlight and then re-emits the energy as heat. This heat causes the object to move slightly in the opposite direction, creating a small but significant force that can affect its trajectory over time. This process, known as the Yarkovsky effect, is commonly seen in smaller bodies like asteroids, but it can also apply to larger objects. In the case of 3I Atlas, the idea was that radiation pressure might have caused the object to accelerate, altering its path in a way that was not predicted by gravitational forces alone. Another possibility was that 3I Atlas was shedding material from its surface in a process similar to sublimation, which is commonly seen in comets. As comets approach the Sun, the heat causes volatile materials like water ice to vaporize, creating a tail of gas and dust. While 3I Atlas did not exhibit a visible tail, it is still possible that it was losing material in a less obvious manner. Some scientists speculated that the object might be composed of a volatile material that was slowly being released as it passed closer to the Sun. This could explain its unusual acceleration, as the loss of mass from the object would cause it to change momentum and move in an unexpected manner. Despite these possible explanations, the true cause of 3I Atlas's acceleration remains uncertain. It is possible that the object's motion is the result of a combination of factors, such as radiation pressure, sublimation, and interactions with the interstellar medium. Alternatively, there may be forces at play that are not yet fully understood. The discovery of 3I Atlas has shown that there is still much to learn about the forces that govern the behavior of interstellar objects, and it has opened up new lines of inquiry into the dynamics of objects traveling between stars. In addition to studying the forces acting on 3I Atlas, scientists were also keenly interested in the object's composition. While the absence of a visible tail suggested that the object was not made primarily of volatile materials, its exact makeup remained a mystery. Observations suggested that it was composed of a dense solid material, possibly rock or metal, similar to the asteroids found in the inner solar system. However, without direct samples, it was impossible to know for sure. Understanding the composition of interstellar objects is crucial for gaining insight into the conditions that prevail in other star systems and how objects in these systems form and evolve. 3I Atlas's composition could offer clues about the processes that take place in the outer reaches of star systems, and studying it may help scientists determine whether other interstellar objects share similar characteristics. The discovery of 3I Atlas has had a profound impact on the field of astronomy, forcing scientists to rethink many of the assumptions they had made about interstellar objects. Before 3I Atlas, the idea of interstellar objects passing through the solar system was largely theoretical. While astronomers had speculated about the possibility of such objects, there had been no definitive evidence of their existence. 3I Atlas's arrival, however, has provided that evidence, and its study has opened up an entirely new field of research. As astronomers continue to track the object's motion and analyze its composition, they will gain a deeper understanding of the nature of interstellar space and the objects that inhabit it. The study of 3I Atlas is just the beginning, and it will undoubtedly lead to further discoveries that will reshape our understanding of the universe. As 3I Atlas continues its path through the solar system, its interactions with the Sun and the interstellar medium provide a unique opportunity for scientists to study the forces that govern the motion of objects from outside our solar neighborhood. The object's rapid movement through the solar system has already provided invaluable data, and its behavior offers critical insights into the dynamics of interstellar space. 3I Atlas's path is an anomaly in many ways, but its study is pushing the boundaries of what we know about celestial mechanics and the physics of space travel. The first of many questions that arise in studying an interstellar object like 3I Atlas is how it interacts with the Sun's gravitational influence. Objects within the solar system follow predictable orbits governed by the Sun's gravity. Comets, asteroids, and other solar system bodies all move in elliptical orbits with gravitational forces shaping their paths. However, 3I Atlas's movement is markedly different. Its trajectory suggests that it is not bound by the Sun's gravity, and it is traveling through the solar system on a hyperbolic path. This means that 3I Atlas will not stay within the solar system, but will continue its journey into deep space, never to return. Its velocity is too high for it to be captured by the Sun's gravity, marking a stark contrast to the behavior of solar system objects that are gravitationally bound to the Sun. One of the most intriguing aspects of 3I Atlas's motion is its acceleration, which has been observed to deviate from what would be expected, based solely on gravitational forces. Objects that pass through the solar system typically experience changes in their velocity due to gravitational slingshot effects when an object swings past the Sun and is accelerated by its gravity. This acceleration, however, is typically predictable and follows well-understood physical principles. In the case of 3I Atlas, its acceleration has been greater than what would be expected based on this slingshot effect, suggesting that another force is at play. Scientists have speculated that the observed acceleration could be due to non-gravitational forces such as radiation pressure. This phenomenon occurs when sunlight strikes an object, causing it to reflect and re-emit energy in the form of heat. This heat release can generate a small but measurable force, which over time can alter the object's trajectory. The Yarkovsky effect is a known force that occurs when the rotation of an object in space causes it to absorb solar radiation and re-emit it as heat, leading to a slight push that can change its orbit. However, the Yarkovsky effect is typically observed in smaller objects, and its influence on a large object like 3I Atlas is still a matter of debate. Some scientists believe that this force could explain part of the unexpected acceleration of the object, but more data will be needed to confirm whether this is the primary cause. Another possibility is that 3I Atlas could be shedding material as it moves through the solar system. Comets often experience sublimation when they approach the Sun, as the heat causes volatile materials on their surfaces to vaporize and stream away from the object, creating a tail of gas and dust. While 3I Atlas has not exhibited the typical tail of a comet, it is still possible that it is slowly losing material in a way that is not immediately visible. This shedding of mass could alter the object's momentum, leading to changes in its speed and trajectory. However, the lack of a visible tail raises questions about the extent to which sublimation is occurring, and it may suggest that 3I Atlas is made up of more solid, stable materials that do not easily vaporize. Despite the possibilities mentioned, the true cause of 3I Atlas's acceleration remains uncertain. The object's motion challenges our current understanding of celestial mechanics, as it does not follow the same patterns seen in solar system objects. This uncertainty highlights the complexity of studying interstellar objects and the many unknowns that still exist in our understanding of space. What makes 3I Atlas particularly fascinating is that it presents a real-world opportunity to observe and analyze forces at work on an object that has traveled across vast distances, moving through space in a way that is not easily explained by our current models. The unusual behavior of 3I Atlas also underscores the need for a more comprehensive understanding of the interstellar medium, the region of space between stars that is filled with gas dust and cosmic radiation. Objects that travel through this medium are subjected to forces that we are still working to fully understand. As 3I Atlas passed through the solar system, its motion was influenced not only by the sun's gravity, but also by the interstellar medium. The effects of this medium on interstellar objects are still a topic of ongoing research, and 3I Atlas offers a unique opportunity to study how these objects interact with the environment between stars. Understanding these interactions will be crucial for the study of future interstellar visitors and may lead to new insights into the dynamics of space. One of the most important aspects of studying 3I Atlas is the opportunity to examine its composition. While the lack of a visible tail suggests that it may not be composed of volatile materials like typical comets, its composition remains an open question. Early observations suggest that 3I Atlas is likely made of solid material, possibly rock or metal, rather than ice. This finding challenges the idea that interstellar objects are primarily icy bodies like comets, and instead suggests that they may be more similar to asteroids. The lack of visible sublimation further supports this idea, as a solid object would not experience the same kind of mass loss that comets undergo when exposed to the sun's heat. Understanding the composition of 3I Atlas will help astronomers learn more about the formation and evolution of interstellar objects. While we have a good understanding of how objects form within star systems, through the accretion of gas and dust, studying objects that come from outside the solar system may reveal new processes that occur in the early stages of planetary system formation in other star systems. The composition of 3I Atlas may offer insights into the types of materials that are prevalent in other star systems, and could contribute to our understanding of how different star systems evolve. The study of 3I Atlas has already led to a rethinking of how we approach interstellar objects and their role in the galaxy. The detection of this object marks the beginning of a new era in astronomy, where objects from outside our solar system are no longer theoretical, but are becoming tangible targets for study. As technology continues to advance, and our ability to detect and track interstellar objects improves, the discovery of more objects like 3I Atlas is inevitable. Each new discovery will offer more data and insights into the behavior and composition of interstellar objects, and will continue to challenge our existing models of space and the forces that shape it. The path of 3I Atlas through the solar system is far from over, but its legacy is already taking shape. By studying this interstellar visitor, astronomers are not only learning about this object, but also laying the foundation for a deeper understanding of the larger processes that govern space. As the object moves farther from the sun, the observations made during its passage will remain a crucial part of the puzzle of interstellar space, guiding the future exploration and study of objects from other star systems. As 3I Atlas continues its journey through the solar system, the increasing attention on its unexpected behavior and enigmatic features has led to a fundamental shift in our understanding of interstellar objects. Unlike typical asteroids or comets, 3I Atlas's trajectory and composition present a unique challenge for astronomers trying to classify it and understand its origins. This object, which has already reshaped how we think about the movement of celestial bodies between stars, is pushing the boundaries of current astronomical models and raising new questions about the forces at work on objects that travel through the vast expanse of interstellar space. One of the most remarkable features of 3I Atlas is its hyperbolic trajectory. This is in stark contrast to the elliptical orbits of objects that are gravitationally bound to the Sun. As 3I Atlas passes through the solar system, its speed and direction suggest that it is not merely a visitor from another part of the solar system, but an object with origins in a distant star system. The fact that its path takes it through our star system without becoming gravitationally captured by the Sun speaks volumes about the forces that govern interstellar objects. Unlike most objects in the solar system, which are bound by the Sun's gravity, 3I Atlas will continue its journey into deep space, never to return. This high velocity raises the question of how common such objects are, and whether we are witnessing the first of many similar interstellar travelers that will pass through the solar system in the future. The high velocity of 3I Atlas also underscores the importance of understanding the dynamics of objects that come from outside the solar system. Objects like comets and asteroids that reside within the solar system follow predictable, stable orbits shaped by the Sun's gravitational pull. However, the hyperbolic trajectory of 3I Atlas suggests that the laws of physics governing its motion are more complex, as it has been affected by forces that we do not yet fully understand. While we can observe the path of such objects accurately predicting their motion, especially when they originate outside the solar system, is far more difficult. The challenges involved in studying interstellar objects like 3I Atlas emphasize the need for the development of new methods and technologies to track objects from distant star systems more effectively. The arrival of 3I Atlas in the solar system also draws attention to the potential risks and opportunities posed by interstellar objects. While the likelihood of an interstellar object colliding with Earth or another planet is remote, the very fact that objects from other star systems can pass through our space with little warning is a stark reminder of the vulnerability of our planet. Though 3I Atlas's path was not in the direct line of collision with any of the solar system's planets, the possibility of future interstellar objects interacting with planets or moons is something that must be considered. As technology advances and our ability to detect objects from outside the solar system improves, astronomers may one day be able to predict when an interstellar object is on a collision course with Earth. In such a scenario, early detection would be crucial for mitigating potential risks, though the probability of a harmful impact remains low. However, the discovery of 3I Atlas has heightened our awareness of the potential hazards posed by interstellar objects, even if they remain unlikely to cause significant damage. The composition of 3I Atlas also continues to spark interest and debate among scientists. Early observations of the object have suggested that it is composed of solid material, likely rock or metal, rather than ice, which is typically found in comets. The absence of a visible tail further supports this hypothesis, as comets are known for shedding gas and dust as they approach the Sun, forming the familiar tail that gives them their distinctive appearance. The fact that 3-eyed Atlas does not exhibit this behavior indicates that it is composed of materials that are far more resilient to the sun's heat, and possibly made up of a mixture of rock and metal, much like the asteroids that reside in the inner solar system. This raises important questions about the origins of interstellar objects and how they form in other star systems. In our own solar system, the materials that make up comets and asteroids are believed to have originated from the early solar nebula, the disk of gas and dust that surrounded the young sun. These objects likely formed as the solar system coalesced billions of years ago, with comets forming in the outer reaches and asteroids forming in the inner regions. However, objects like 3I Atlas, which come from other star systems, may have had very different formation processes, depending on the conditions in their home star systems. By studying 3I Atlas's composition, astronomers hope to gain insight into the conditions that exist in other star systems and learn more about the processes that govern the formation of planetary bodies beyond our own. Understanding the composition of 3I Atlas could also help astronomers understand the prevalence of objects like it in the galaxy. While we have limited knowledge of the specific types of objects that exist in other star systems, the study of interstellar objects like 3I Atlas provides a glimpse into the wider population of objects that exist between stars. If 3I Atlas is indeed composed of rock and metal, it could suggest that interstellar space is populated by many similar objects, solid, resilient bodies that have traveled great distances across the galaxy. The presence of such objects may offer clues about the types of material that exist in other star systems and how these materials might be distributed across the galaxy. In addition to these scientific insights, the discovery of 3I Atlas has sparked broader discussions about the future of space exploration. As humanity moves toward the possibility of exploring other star systems, the study of interstellar objects could play an essential role in preparing for interstellar travel. If we are to send spacecraft to other stars in the future, understanding the behavior of interstellar objects like 3I Atlas will be crucial for navigating the vast distances between stars. The discovery of interstellar objects also emphasizes the need for developing spacecraft capable of withstanding the harsh conditions of interstellar space, where objects travel at high velocities, subject to forces that are not fully understood. 3I Atlas, in its unexpected path through the solar system, serves as a reminder of the unknowns that still exist in space and the importance of preparing for the challenges of interstellar exploration. Finally, 3I Atlas represents an exciting opportunity for astronomers to explore the broader universe. The discovery of this object forces a rethinking of what is possible in the study of objects beyond the solar system. It shows that the universe is not only much larger than we imagined, but that objects from distant stars may play a significant role in the dynamics of our own solar system. By continuing to study 3I Atlas, scientists are not only uncovering the mysteries of this one object, but are also laying the groundwork for future discoveries that could transform our understanding of space-time and the universe itself. As 3I Atlas continues its path out of the solar system, the questions it raises about the behavior of interstellar objects remain a central topic of scientific inquiry. The study of its motion composition and acceleration is helping to reshape our understanding of the forces that influence objects from outside our star system. One of the key aspects of 3I Atlas's passage through the solar system has been its unexpected acceleration, which has prompted astronomers to reconsider how interstellar objects move and interact with the space around them. While most objects in the solar system follow predictable orbits determined by the Sun's gravitational influence, 3I Atlas's acceleration has challenged our understanding of celestial mechanics and the forces at work on interstellar objects. The acceleration of 3I Atlas is not a simple result of gravitational forces. Typically, objects in the solar system experience gravitational slingshot effects when they pass near the Sun, which causes them to accelerate slightly. However, the amount of acceleration expected from this process is small and predictable, and it is usually not enough to explain the dramatic changes in velocity observed in objects like 3I Atlas. Instead, astronomers have been forced to explore other possible explanations for the object's acceleration. One possibility is radiation pressure, a force caused by the sun's light striking an object and imparting a small amount of momentum. This effect is well known in the context of comets, where radiation pressure from the sun helps to drive the release of gas and dust, forming the characteristic tail. In the case of 3I Atlas, radiation pressure might be playing a role, but the absence of a visible tail suggests that other factors could be involved as well. Another possibility that has been considered is sublimation, the process by which solid material turns directly into gas when heated. This is a well-known phenomenon in comets, where the heat from the sun causes ices on the surface to vaporize, creating a coma and a visible tail. While 3I Atlas has not exhibited these typical cometary features, it is still possible that it is losing material in a way that is not immediately visible. This could be a much slower process, with the object releasing only small amounts of gas or dust as it passes through the solar system. If this were the case, the loss of material could alter the object's momentum, resulting in the observed acceleration. However, the lack of a visible tail makes it difficult to confirm whether sublimation is occurring, and this remains an area of active research. The study of 3I Atlas's acceleration highlights an important challenge in understanding interstellar objects. The forces acting on these objects are not fully understood. While we have a good understanding of the physics governing objects within the solar system, interstellar objects like 3I Atlas behave in ways that do not always conform to the models we use for solar system bodies. These objects travel across vast distances of space, often encountering conditions that are vastly different from those found within star systems. As 3I Atlas moves further from the Sun, its interaction with the interstellar medium made up of gas and dust between stars will likely become more pronounced. The effects of this medium on objects like 3I Atlas are still poorly understood, and studying this interaction will be crucial for developing a more complete picture of how interstellar objects behave. In addition to the acceleration of 3I Atlas, the object's composition remains a subject of great interest. Observations have suggested that 3I Atlas is made primarily of solid material, possibly rock or metal, rather than the icy materials typically found in comets. This composition is a key feature that sets it apart from other objects in the solar system. The lack of visible sublimation or a cometary tail suggests that 3I Atlas may be more similar to an asteroid than a typical comet. The absence of volatile substances like water ice raises the possibility that 3I Atlas formed in a different environment, perhaps in a star system that had conditions more similar to the inner regions of the solar system. Studying the composition of 3I Atlas is crucial for understanding where it came from and how it fits into the larger picture of interstellar objects. 3I Atlas's composition also offers important clues about the materials that exist in other star systems. If the object is composed of rock or metal, it could suggest that interstellar space is populated by many similar objects, solid bodies that have traveled across the galaxy. This has implications for our understanding of how planets and planetary systems form. The study of interstellar objects could reveal whether the same types of materials that make up the planets in our solar system are also present in other star systems. If these materials are common across the galaxy, it could suggest that the processes that govern the formation of planetary bodies are universal, occurring in much the same way throughout the cosmos. On the other hand, if 3I Atlas is made of materials that are not commonly found in our solar system, it could indicate that the conditions in other star systems are vastly different from those in our own. The discovery of 3I Atlas also raises important questions about the potential for interstellar objects to interact with the planets and moons of our solar system. While 3I Atlas did not pose a threat to Earth, the possibility of other interstellar objects passing through the solar system raises concerns about the potential risks they might present. The gravitational interactions between an interstellar object and the planets could have significant effects, potentially altering the orbits of other objects in the solar system. For example, if an interstellar object were to pass too close to one of the outer planets, it could perturb the orbits of nearby comets or asteroids, sending them on a collision course with the inner planets. While the probability of such an event occurring is low, the discovery of 3I Atlas has raised awareness of the potential hazards posed by interstellar objects. In addition to the potential risks, interstellar objects could also offer unique opportunities for scientific discovery. The study of objects from other star systems could provide us with insights into the conditions that exist beyond our own solar system. Objects like 3I Atlas could be carrying information about the formation and evolution of other star systems, offering a snapshot of a distant star system's early history. The composition of interstellar objects could tell us about the materials that are present in other parts of the galaxy, and studying their motion could reveal how objects move through interstellar space. As more interstellar objects are discovered and studied, we will gain a deeper understanding of the processes that govern the universe, shedding light on the origins of our own solar system and the forces that shape the cosmos. The study of 3I Atlas has already expanded our understanding of interstellar space and the objects that travel through it. As we continue to track the object's motion and analyze its behavior, we are learning more about the forces that influence its movement and the composition of interstellar objects. While 3I Atlas's time in the solar system has been brief, its impact on the field of astronomy will be lasting. The data collected from its passage will continue to shape future research, as scientists refine their models of interstellar object dynamics and develop new methods for detecting and studying objects from outside the solar system. The study of 3I Atlas represents the beginning of a new era in space exploration, one in which the study of interstellar objects plays a central role in our understanding of the universe. As we look to the future of astronomical discovery, the passage of 3I Atlas through the solar system marks a pivotal moment in the exploration of interstellar space. Though the object has already passed beyond the reach of our telescopes, the insights gained from its brief visit continue to influence the scientific community. The discovery of 3I Atlas represents more than just the observation of a single object. It signals the beginning of a new era in which interstellar objects become a key focus of research, shedding light on the nature of the galaxy, the formation of star systems, and even the potential for life beyond Earth. The lessons learned from studying 3I Atlas are not only reshaping our understanding of space, but they are also laying the groundwork for future discoveries that will expand our knowledge of the cosmos. The passage of 3I Atlas has forced astronomers to rethink many of their assumptions about the objects that exist in interstellar space. Prior to the discovery of 3I Atlas, the idea of objects traveling between star systems was largely theoretical. While astronomers had speculated about the existence of interstellar objects, there was no concrete evidence to support these theories. 3I Atlas, however, provided that evidence and confirmed that interstellar objects do indeed exist. The object's unexpected arrival in the solar system has prompted scientists to reconsider the frequency with which such objects might be passing through our space, as well as the potential for future interstellar visitors. The fact that 3I Atlas was detected at all due to the sensitivity of current detection methods suggests that there may be many more interstellar objects lurking in the depths of space waiting to be discovered. One of the most significant revelations of 3I Atlas's passage is the potential for interstellar objects to serve as messengers from distant star systems. These objects have likely traveled vast distances across the galaxy, and in doing so, they carry information about the environments from which they originated. By studying their composition, trajectory, and motion, scientists can glean insights into the conditions that exist in other parts of the galaxy. For example, the composition of 3I Atlas suggests that it may have formed in a star system with conditions different from our own. The object's lack of volatile materials, such as water ice, challenges our assumptions about the types of materials that can be found in other star systems, and suggests that the process of planetary formation may vary depending on the environment. The study of 3I Atlas also highlights the interconnectedness of the universe. Our solar system, once thought to be a relatively isolated system, is now understood to be part of a much larger cosmic network. Interstellar objects like 3I Atlas remind us that our star system is not static, but is constantly interacting with the wider galaxy. The movement of these objects through interstellar space is a reminder of the dynamic nature of the cosmos. While objects like 3I Atlas are relatively rare, they provide a glimpse into the larger forces at play in the galaxy. The passage of such objects is a reminder that the universe is in constant motion, and that the forces that shape star systems and planetary bodies extend far beyond the confines of our own solar system. The discovery of 3I Atlas has also brought attention to the potential risks posed by interstellar objects. Although the likelihood of an interstellar object colliding with Earth or another planet is low, the very fact that objects from outside the solar system can pass through our space with little warning raises important questions about the vulnerability of our planet. The passage of 3I Atlas was a close call in the sense that its trajectory brought it relatively close to Earth, though no direct interaction occurred. As more interstellar objects are discovered, it will be essential to monitor their paths and assess any potential risks they may pose. While the chances of a catastrophic impact remain extremely small, the possibility of smaller impacts with asteroids or comets is still something that must be considered. Understanding the dynamics of interstellar objects and developing methods to track them more effectively will be key to safeguarding our planet in the future. The detection of 3I Atlas has also highlighted the need for better detection methods for interstellar objects. While the object's passage was detected by the Atlas survey, which was designed to monitor near-Earth objects, the ability to detect interstellar visitors is still in its early stages. Given the vastness of space and the speed at which interstellar objects travel, it is difficult to predict when such objects will appear in the solar system, making early detection all the more important. The success of 3I Atlas's detection has shown that it is possible to spot these objects with the right technology, but it also highlights the need for more sophisticated tracking systems to identify objects long before they reach the inner solar system. As technology advances, astronomers will be able to monitor the skies more effectively and detect interstellar objects with greater precision. The study of 3I Atlas also has implications for the search for extraterrestrial life. The idea that interstellar objects could be carriers of organic material has gained increasing attention in recent years, with the hypothesis that objects like 3I Atlas could potentially deliver the building blocks of life between star systems. While there is currently no evidence to suggest that 3I Atlas contains life-related molecules, the possibility that objects from other star systems might harbor the ingredients for life raises exciting questions about the spread of life throughout the galaxy. This concept, known as panspermia, suggests that life might not be confined to Earth, but could be widespread across the universe. The study of interstellar objects like 3I Atlas may help scientists understand whether the conditions for life are more common than previously thought, and whether life could exist elsewhere in the galaxy. The discovery of 3I Atlas has also sparked interest in the future of interstellar exploration. While we are still a long way from sending humans to other star systems, the study of interstellar objects is helping to lay the groundwork for the possibility of interstellar travel. The movement of 3I Atlas through the solar system has already provided valuable insights into the challenges and opportunities that await future interstellar missions. The object's high velocity and its interaction with the interstellar medium have shown that traveling between stars is far more complex than simply traveling within a single star system. The study of interstellar objects will help scientists design spacecraft capable of navigating the vast distances between stars and could eventually lead to missions that explore the stars and their planets up close. In conclusion, the passage of 3I Atlas through the solar system has had a profound impact on our understanding of the universe. The discovery of this interstellar object has opened a new frontier in space exploration, one that will continue to yield valuable data for years to come. Whether it is providing insights into the composition of distant star systems, raising questions about the potential risks posed by interstellar objects or inspiring the next generation of space explorers, 3I Atlas has already changed the way we view the cosmos. As we continue to study this object and others like it, we will expand our knowledge of interstellar space, the forces that shape it, and our place in the galaxy. The legacy of 3I Atlas is not just in the data it has provided, but in the new questions it has raised and the doors it has opened for future discovery. The movement of 3I Atlas through the solar system has sparked not only scientific curiosity, but also significant discussion about the broader implications of interstellar objects. Its unexpected arrival was a reminder of the dynamic and unpredictable nature of the universe. Objects like 3I Atlas force scientists to reconsider not just the nature of space and the objects within it, but also the very way in which we view the forces that govern celestial dynamics. In the study of 3I Atlas, we find not only a new puzzle to solve, but also an opportunity to refine our understanding of the cosmos and to explore new pathways for scientific discovery. One of the biggest implications of studying 3I Atlas is the realization that objects from outside the solar system are more likely to pass through our space than previously thought. The object's hyperbolic trajectory and high velocity are a stark reminder that the solar system is not a completely isolated system, but rather one that is part of a dynamic and interconnected galaxy. For years, astronomers assumed that objects from other star systems would be incredibly rare, but 3I Atlas has changed that assumption. If more interstellar objects are discovered, this could drastically alter our understanding of how material moves between star systems. These objects are not only traveling through space, they are interacting with our solar neighborhood, leaving traces that can be observed and studied. 3I Atlas has shown that objects like it could potentially influence the solar system in ways we did not fully anticipate. The high velocity of 3I Atlas is also a significant factor in understanding how objects from outside the solar system behave when they enter our space. The object's motion is much faster than that of typical solar system objects, which means that it has a limited time within the solar system to be studied. As a result, 3I Atlas's passage was brief but packed with scientific value. If similar objects are discovered, it will be essential for astronomers to develop faster methods for tracking them, as well as techniques to better understand their movement through the solar system. This will require advances in both the speed of detection and the tools used to track interstellar visitors across vast distances of space. While the study of 3I Atlas was a unique opportunity, the next interstellar object to enter the solar system could require a more immediate response from the astronomical community, as scientists strive to make the most of the brief window of time available for research. In addition to its unusual velocity, 3I Atlas's lack of typical cometary features has led to new questions about how objects from other star systems form and behave. Unlike most comets, which are made up of a mixture of ice dust and gas, 3I Atlas seems to be composed primarily of solid rock or metal. This suggests that the object's origins lie in a star system where the conditions for the formation of icy bodies, such as those found in the outer reaches of the solar system, did not exist. Instead, 3I Atlas may have formed in the inner regions of its home star system, where temperatures were too high for volatile compounds like water to condense. This idea has implications for how we understand the distribution of materials in other star systems. If 3I Atlas is typical of the types of objects found in the inner regions of other star systems, it could help astronomers refine their models of planetary system formation, particularly in regions of space that are warmer and more volatile. Moreover, the composition of 3I Atlas suggests that its interstellar journey has been long and eventful. Objects that travel through interstellar space encounter a variety of forces and environmental factors that can alter their shape and composition. The interstellar medium, a diffuse mixture of gas and dust that fills the space between stars, can cause objects to erode over time, and cosmic radiation can strip away material from their surfaces. The fact that 3I Atlas has managed to survive its journey through the galaxy and remain intact as it enters the solar system is a remarkable testament to the resilience of interstellar objects. This raises the question of how common such resilient objects are, and whether other interstellar objects are similarly composed of robust materials that can withstand the harsh conditions of interstellar space. The study of 3I Atlas will help astronomers understand whether this type of resilience is common among interstellar objects or if it is an anomaly. As we study 3I Atlas and its behavior, it is becoming clear that the object's passage through the solar system has important implications for the study of space exploration. Interstellar objects like 3I Atlas present both challenges and opportunities for future missions to explore the stars. While missions to other star systems are still far in the future, the study of interstellar objects can inform the design of spacecraft that could one day travel to distant stars. 3I Atlas's high velocity and trajectory offer clues about how spacecraft might navigate interstellar space and the forces that they would encounter along the way. The knowledge gained from studying 3I Atlas could also help refine propulsion technologies, making interstellar travel more feasible in the future. As we learn more about how interstellar objects move through space, we will gain a deeper understanding of the complexities involved in traveling between stars, helping to shape the next generation of space exploration technologies. The broader significance of 3I Atlas extends beyond its composition and trajectory. Its discovery serves as a reminder that the universe is vast and full of unexpected surprises. The object's passage through the solar system challenges our understanding of space and forces us to confront the unknown. It is easy to imagine that the universe is a predictable and ordered place, but the arrival of 3I Atlas shows that there are forces at work in the galaxy that we do not yet fully understand. This realization has profound implications for our view of the cosmos and the way we study it. Objects like 3I Atlas challenge our assumptions and encourage us to keep searching for answers to questions we never thought to ask. This sense of wonder and curiosity is what drives the field of astronomy forward, and the study of interstellar objects like 3I Atlas is an essential part of that ongoing journey. Furthermore, the discovery of 3I Atlas has implications for the search for extraterrestrial life. While there is no evidence to suggest that 3I Atlas contains life, the fact that it has traveled across such vast distances of space without disintegrating raises the possibility that interstellar objects could play a role in the distribution of life's building blocks. The idea of panspermia, the hypothesis that life or its ingredients could be spread throughout the galaxy by objects like 3I Atlas, has gained traction in recent years. Although the search for organic material on 3I Atlas is ongoing, the possibility that life could travel between star systems is an exciting avenue of research. If objects like 3I Atlas can carry organic molecules across the galaxy, it could change the way we search for life beyond Earth and offer new clues about the origins of life itself. In conclusion, the discovery of 3I Atlas has already forced a major rethink of interstellar objects and their role in the universe. The object's unique characteristics and behavior challenge our existing models of space, and its study has opened up new lines of inquiry into the nature of the forces that shape the cosmos. As we continue to monitor 3I Atlas's path and analyze its composition, we are not just studying a single object. We are gaining insights into the larger processes that govern the movement of objects between stars and the conditions that prevail in other parts of the galaxy. The impact of 3I Atlas's discovery will continue to shape our understanding of the universe for years to come. And as we uncover more interstellar objects, we will be able to build a more complete picture of the galaxy and our place within it. As the journey of 3I Atlas continues to unfold, its influence on the scientific community remains profound. While the object's passage through the solar system was a fleeting event, its impact is far-reaching. The data collected during this brief encounter is already reshaping our understanding of interstellar space and the behavior of objects from beyond our solar neighborhood. The passage of 3I Atlas serves as a unique moment in history, highlighting the dynamic nature of the universe and the many mysteries that remain just beyond our reach. As we continue to study this interstellar visitor, we begin to recognize the broader implications it holds for both the scientific community and humanity's place within the cosmos. One of the most significant revelations to emerge from the study of 3I Atlas is the realization that objects from outside the solar system are not as rare as previously believed. Before its discovery, scientists had only speculated about the existence of interstellar objects passing through our space. While astronomers had theorized that objects like comets and asteroids could travel between star systems, there had been no definitive proof of this phenomenon. 3I Atlas, however, confirmed that objects from other stars can indeed enter the solar system, and its detection suggests that interstellar objects may be more common than we once thought. If 3I Atlas is only the first of many such objects, the implications for our understanding of space and our position in the galaxy are profound. The study of 3I Atlas has sparked interest in the potential for future interstellar discoveries. As astronomers refine their detection methods, it is likely that more interstellar objects will be identified in the coming years. The passage of 3I Atlas through the solar system was a rare event, but the increasing sensitivity of telescopes and observation systems makes it more likely that similar objects will be discovered in the future. This could lead to an entirely new field of astronomical study, one that focuses on the dynamics of interstellar space and the objects that travel between stars. The possibility of more interstellar visitors challenges our previous assumptions about the nature of space and our place within it, opening up new avenues of exploration. The discovery of 3I Atlas has also raised important questions about the role of these objects in the larger context of the galaxy. While objects like comets and asteroids are thought to be remnants from the early days of the solar system, interstellar objects are far more mysterious. Their origins lie in distant star systems, and their presence in the solar system raises important questions about the movement of matter across the galaxy. 3I Atlas's journey across vast distances of space serves as a reminder that the universe is far more interconnected than we once thought. The dynamics of the galaxy are not limited to the gravitational interactions between stars and planets. They extend far beyond, with objects moving between stars and across interstellar space. In studying 3I Atlas, scientists are gaining a deeper understanding of the conditions that prevail in interstellar space. The object's composition, behavior, and movement provide valuable information about the environment between stars. Interstellar space is not a perfect vacuum, as it contains gas, dust, and radiation, all of which can affect the motion and characteristics of objects passing through it. By studying 3I Atlas, scientists are learning more about the forces that govern the movement of objects across the galaxy and how these forces shape the evolution of celestial bodies. The data gathered from 3I Atlas's passage will help refine models of interstellar dynamics, providing insights into the long-term behavior of objects that travel between stars. The unexpected acceleration of 3I Atlas has also raised important questions about the forces that affect interstellar objects. While gravitational forces from the Sun are the primary influence on objects within the solar system, the motion of 3I Atlas cannot be fully explained by gravity alone. The object's acceleration, which was observed to be greater than expected, based on gravitational interactions, suggests that other forces are at play. Radiation pressure, which occurs when sunlight exerts a small force on an object, is one possible explanation. However, the lack of a visible tail or coma suggests that other factors, such as sublimation or interactions with the interstellar medium, may be influencing the object's motion. Understanding the forces acting on 3I Atlas is critical to refining our models of interstellar object behavior and will help scientists develop a more comprehensive understanding of the dynamics of objects in space. In addition to its acceleration, the composition of 3I Atlas has also sparked interest. Observations suggest that the object is primarily composed of solid material, such as rock or metal rather than ice. This composition sets it apart from typical comets, which are made up of volatile materials like water ice and gas. The fact that 3I Atlas does not exhibit the typical behavior of a comet, such as the release of gas and dust as it approaches the Sun, suggests that it may have formed in a different environment than the icy bodies that populate the outer reaches of the solar system. This raises important questions about the formation of interstellar objects and the conditions that prevail in other star systems. If 3I Atlas is representative of the types of objects found in other star systems, it could suggest that the materials found in these systems are more similar to those in the inner regions of our solar system, where solid materials are more prevalent than volatile substances. The discovery of 3I Atlas has also raised the possibility that interstellar objects could play a role in the delivery of material between star systems. While there is no direct evidence to suggest that 3I Atlas carries life-related molecules, the idea that interstellar objects could act as carriers of organic material has gained increasing attention. The concept of panspermia, which suggests that life or its building blocks could be spread across the galaxy by objects like 3I Atlas, has gained traction in recent years. While the theory remains speculative, the possibility that interstellar objects could deliver the ingredients for life to other star systems has profound implications for the search for extraterrestrial life. If objects like 3I Atlas can carry organic molecules across vast distances, it suggests that life may be more widespread in the galaxy than previously thought. The study of 3I Atlas also has significant implications for future space exploration. As humanity looks toward the possibility of interstellar travel, the study of interstellar objects can provide valuable insights into the challenges and opportunities of traveling between stars. Objects like 3I Atlas, which have traveled vast distances across the galaxy, can help inform the design of spacecraft capable of navigating interstellar space. Understanding how interstellar objects interact with the interstellar medium, as well as the forces that influence their motion, will be crucial for the development of spacecraft that can survive the harsh conditions of interstellar space. The knowledge gained from studying 3I Atlas will help guide the next generation of space exploration missions and pave the way for humanity's future in the stars. In conclusion, the discovery of 3I Atlas has opened up a new era in our understanding of interstellar space and the objects that travel through it. The object's passage through the solar system has provided invaluable data that will continue to inform the study of interstellar objects for years to come. Whether it is offering insights into the forces that shape the motion of objects between stars, challenging our assumptions about the composition and behavior of interstellar objects, or inspiring the next wave of space exploration, 3I Atlas has had a profound impact on the scientific community. As we continue to study this interstellar visitor, we are reminded of the vastness and interconnectedness of the universe and the many mysteries that remain to be discovered. The discovery of 3I Atlas and the study of its brief passage through the solar system have triggered a broad reevaluation of many aspects of space science, particularly when it comes to understanding the motion and composition of objects that originate from outside our star system. As more data is collected and analyzed, astronomers are refining their models to accommodate the complexities introduced by interstellar objects. What makes the study of 3I Atlas particularly exciting is not only what it reveals about this singular object, but also what it teaches us about the wider universe and our place in it. This unprecedented object has opened a new field of inquiry in the exploration of interstellar space, pushing the boundaries of current astronomical knowledge. One of the major revelations that came from studying 3I Atlas was the realization that interstellar objects are not only rare occurrences, but could be relatively common. Before its detection, the notion of interstellar objects moving through our solar system was largely speculative, with astronomers unsure whether such objects even existed. The discovery of 3I Atlas has proved that objects from other stars do indeed pass through our star system. And if 3I Atlas is any indication, more interstellar objects may already be traveling through space unnoticed. The key takeaway is that interstellar objects are not just theoretical, and their study is becoming an important area of research for understanding the broader dynamics of the galaxy. While 3I Atlas's speed and trajectory were unique, they also sparked interest in the concept of cosmic highways. The idea that objects from other star systems may regularly travel through interstellar space, crossing paths with other star systems, including our own. This potential for cosmic traffic has vast implications for how we think about the movement of matter in the galaxy. The discovery of 3I Atlas, combined with the insights it provides into the movement of objects between stars, means that the study of these objects could provide clues about the nature of the interstellar medium, the region of space between stars that is often thought of as an empty void. In fact, it is now understood to be full of gas dust and other materials, and the objects that travel through it may interact with these elements in ways that we are only beginning to comprehend. This realization has a direct bearing on our understanding of how objects form in other star systems. Studying 3I Atlas has forced scientists to reconsider how material is distributed in the interstellar medium, and how objects like comets, asteroids, and other bodies come to exist in different star systems. The object's composition, likely a mixture of rock and metal, suggests that it may have formed under conditions that are very different from those of the solar system, perhaps in a star system with a different chemical makeup or environmental conditions. 3I Atlas's lack of a visible tail typical of comets suggests that its formation occurred in a hotter region of its parent star system, where volatile compounds like water ice might not have had a chance to condense. This discovery is key for understanding the conditions that prevail in other star systems and provides a glimpse into the diversity of planetary and object formation processes across the galaxy. Furthermore, the passage of 3I Atlas has raised significant questions about how objects like it might influence the solar system. While 3I Atlas did not have any direct impact on the planets or other bodies in the solar system, the fact that an object could travel from a distant star system and interact with our own space is a reminder of the potential for unexpected and unpredictable influences. As interstellar objects pass through the solar system, they may perturb the orbits of smaller bodies like comets or asteroids, potentially redirecting them toward the inner solar system or altering their paths in subtle ways. This has important implications for the study of space hazards and the need for better monitoring systems to track interstellar objects as they pass through our region of space. While the likelihood of a major collision with Earth is extremely low, the passage of 3I Atlas serves as a reminder that even objects traveling at high speeds can influence the dynamics of the solar system. As more interstellar objects are discovered, the focus will likely shift from just detecting them to understanding the long-term effects they may have on the solar system. For instance, what influence do these objects have on the larger cosmic structure around us? The study of their interaction with the interstellar medium could yield significant information about how matter behaves on a galactic scale. More interstellar objects will likely be found as observational technology improves, and each new object will offer valuable data to refine our understanding of the mechanics of interstellar space. While studying these objects provides fascinating scientific insights, it also opens the door for potential breakthroughs in our search for extraterrestrial life. The concept of panspermia, the idea that life or its building blocks could be transported across the galaxy by interstellar objects, has been gaining attention in recent years. 3I Atlas, with its interstellar origins, serves as a natural candidate for the study of this hypothesis. If the object has carried organic material on its journey across the stars, it may provide clues about how life, or at least the raw ingredients for life, could spread across the galaxy. Though there is no direct evidence linking 3I Atlas to the origins of life, the idea that objects like it could play a role in seeding life on other planets raises intriguing possibilities for the future of astrobiology. In addition, the study of interstellar objects like 3I Atlas could inform the development of space exploration technologies. As humanity looks toward the future and the possibility of interstellar travel, understanding how objects from other stars travel through space is crucial. By studying the characteristics of 3I Atlas and similar objects, scientists can learn more about the forces that shape the movement of objects between stars, as well as the challenges that spacecraft will face as they travel across vast interstellar distances. The high speed of 3I Atlas provides a real-world example of how fast objects move through space, and the lessons learned from its study can help guide the design of future space missions to distant stars. If interstellar travel is to become a reality, understanding the environment of interstellar space and the behavior of objects like 3I Atlas will be essential for ensuring the success of future missions. The importance of 3I Atlas's passage cannot be overstated, as it has already led to new insights into the dynamics of interstellar space. It has shown us that objects from outside the solar system are not just rare anomalies, but rather an important part of the galactic landscape. The discovery of this object has given rise to new questions about the conditions in other star systems, the potential risks posed by interstellar objects, and the role of these objects in the broader dynamics of the galaxy. As we continue to track and study 3I Atlas and similar interstellar objects, we will uncover more about the universe and the forces that govern it. The discoveries we make today will shape our understanding of the cosmos for generations to come, offering new perspectives on our place in the universe. The legacy of 3I Atlas will not only be in the data it has provided, but also in the way it has expanded our view of space and challenged our assumptions about the universe. It has forced us to rethink what we know about objects in the galaxy and has opened up new possibilities for the future of space exploration and our understanding of life beyond Earth. The discovery of 3I Atlas is just the beginning of a new era in astronomy, one in which interstellar objects play a central role in our quest for knowledge. As more objects are discovered, we will continue to push the boundaries of science, uncovering the secrets of the galaxy and gaining a deeper understanding of the forces that shape the universe. The discovery and study of 3I Atlas represents a watershed moment in the history of astronomy, offering a glimpse into the far reaches of interstellar space and the objects that traverse it. As 3I Atlas moves further from the solar system, its legacy remains not just in the data collected from its passage, but in the way it has reshaped our understanding of the universe. The questions it raises about interstellar objects are far from answered, and yet the study of this singular object has already yielded profound insights into the mechanics of space. What makes 3I Atlas especially significant is the broader shift it has prompted in how we think about the movement of matter across vast cosmic distances and the very forces that shape the behavior of celestial bodies. The path of 3I Atlas through the solar system was a reminder that our star system is far from isolated. Until its arrival, many had thought of our solar system as a self-contained region of space with interactions mostly limited to the Sun and the objects that orbit it. However, 3I Atlas's passage through our space demonstrated that the solar system is part of a much larger galactic environment where objects from other stars can and do travel between star systems. The object's hyperbolic trajectory, combined with its speed and unexpected acceleration, has opened a new chapter in our understanding of how objects move through interstellar space and interact with the environments of different star systems. It raises the possibility that the galaxy is not a static collection of stars, but rather a dynamic and interconnected system, where objects can move freely between star systems, influencing and being influenced by the gravitational forces, radiation, and matter they encounter. The fact that 3I Atlas was detected at all is a testament to the advancements in technology and the growing sensitivity of telescopes and observational tools. Before its discovery, astronomers had long speculated that objects from other star systems might occasionally pass through the solar system, but the likelihood of detection seemed slim given the vastness of space. The ability to observe 3I Atlas as it entered the solar system demonstrates the potential of modern technology to expand our understanding of the cosmos. It also underscores the importance of continually improving our methods for tracking objects that are outside the solar system. As we develop more sensitive detection systems, the likelihood of finding additional interstellar objects will increase, and the wealth of data we collect from their passage will further deepen our knowledge of the dynamics of interstellar space. While the detection of 3I Atlas marked a significant achievement, its presence has also spurred new discussions about how such objects may affect the solar system. The passage of 3I Atlas through our space was, of course, a relatively benign event, but the possibility remains that future interstellar objects could have a more direct impact on the solar system. Although the chances of an object of this nature colliding with Earth are extremely low, the influence of such objects on smaller bodies like asteroids or comets is something that cannot be discounted. For example, a close encounter with a large interstellar object could perturb the orbits of smaller objects in the solar system, potentially redirecting them toward Earth or other planets. The presence of 3I Atlas serves as a reminder that even objects that are not gravitationally bound to our star system can have an impact on its structure. Understanding how interstellar objects interact with solar system bodies is an area of growing importance, and the study of 3I Atlas has provided a valuable foundation for future research in this area. The unique characteristics of 3I Atlas have also raised questions about the nature of the interstellar medium. Objects like 3I Atlas, which travel across vast distances of space, encounter the diffuse gas and dust that fills the space between stars. These interactions may affect the structure and composition of interstellar objects, but they are not well understood. The movement of 3I Atlas through the solar system, coupled with its acceleration, suggests that the interstellar medium plays a significant role in the behavior of objects traveling through it. While the effects of the interstellar medium on interstellar objects are still being studied, it is clear that this medium cannot be ignored when considering the dynamics of space. 3I Atlas's passage offers valuable data about how objects interact with this medium, and the lessons learned from its study will guide future research into the nature of the interstellar environment. In addition to its impact on our understanding of space, 3I Atlas also holds significant potential for future space exploration. As humanity moves toward the goal of exploring interstellar space, the study of objects like 3I Atlas is essential for preparing for the challenges that await. The object's high velocity and the forces it encountered as it passed through the solar system provide valuable insight into how spacecraft could navigate the vast distances between stars. By studying 3I Atlas's motion and the forces at work on it, scientists can refine their models of interstellar space travel. If we are to one day send spacecraft beyond the solar system, understanding how interstellar objects behave is crucial for ensuring the success of future missions. The data from 3I Atlas is in a sense a test run for the challenges we may face as we seek to send spacecraft to distant stars. 3I Atlas also highlights the importance of studying objects from other star systems in the search for life beyond Earth. The idea that interstellar objects could serve as vehicles for the transport of organic material, or even life itself, has gained traction in recent years. While there is no evidence to suggest that 3I Atlas contains life, its passage through the solar system has revived interest in the possibility that life's building blocks could be spread across the galaxy by objects like 3I Atlas. This idea, known as panspermia, proposes that life or its precursors could travel between stars on the surfaces of comets, asteroids, or other objects. While the theory remains speculative, the discovery of 3I Atlas has given scientists a new reason to explore the possibility that life could be more widespread in the galaxy than previously thought. The study of 3I Atlas has already proven invaluable, but it has also raised more questions than answers. As scientists continue to study the data gathered from its passage through the solar system, they will undoubtedly uncover more information about its composition, behavior, and the forces that shape its movement. Each new discovery will help refine our understanding of interstellar objects, the interstellar medium, and the broader dynamics of space. The study of 3I Atlas is a reminder that the universe is vast and filled with mysteries, and that even the most unexpected events can lead to profound scientific breakthroughs. As we continue to explore the unknown, 3I Atlas will remain a key milestone in our understanding of the cosmos, guiding future research and inspiring generations of scientists to seek out new frontiers. In conclusion, the discovery and study of 3I Atlas have had a profound impact on our understanding of interstellar objects and the broader universe. The object's brief passage through the solar system has provided valuable data that will continue to shape the study of interstellar space for years to come. While its journey through the solar system is now coming to an end, its legacy will live on in the knowledge it has imparted, the questions it has raised, and the discoveries it has inspired. As we continue to explore the universe, the study of objects like 3I Atlas will remain essential to our quest for knowledge, helping us understand not only the objects themselves, but also the forces that govern the vast and interconnected galaxy in which we live. As the study of 3I Atlas unfolds, its impact continues to reverberate across the scientific community. The object's passage through the solar system, though brief, has sparked a wave of new questions about interstellar space, the dynamics of interstellar objects, and the role such objects play in shaping the broader structure of the galaxy. As more interstellar objects are detected and studied, the legacy of 3I Atlas will serve as a foundational reference point for future research. It is increasingly clear that the discovery of 3I Atlas is only the beginning of a larger shift in the way we study space objects that travel between stars and the forces that influence their movement. One of the most important takeaways from the study of 3I Atlas is that the solar system is not an isolated entity, but rather part of a dynamic, interconnected galaxy. The arrival of 3I Atlas serves as a reminder that objects from outside the solar system are constantly passing through our space, moving through the vast expanse of interstellar space. While we often think of the solar system as a self-contained region of space, the passage of 3I Atlas and similar objects has revealed that the universe is far more interconnected and dynamic than we ever imagined. The movement of objects between star systems raises important questions about the movement of matter on a galactic scale, and the discovery of 3I Atlas is a stepping stone toward a broader understanding of this cosmic flow. In addition to its impact on our understanding of the galaxy, 3I Atlas has also forced astronomers to rethink the way interstellar objects behave. Unlike typical solar system objects, which are often gravitationally bound to the Sun, 3I Atlas follows a hyperbolic trajectory that ensures it will leave the solar system and never return. This high velocity and unique path through the solar system were a clear sign that 3I Atlas was not a typical asteroid or comet. Its motion demonstrated that interstellar objects are not subject to the same gravitational constraints as solar system bodies, and that their trajectories could be far more unpredictable. The discovery of this object has raised important questions about how interstellar objects move through space and what forces act on them as they travel between stars. The fact that 3I Atlas is not gravitationally bound to the Sun, but is simply passing through our space, has important implications for our understanding of how objects move within star systems. For example, while the Sun's gravity influences the orbits of planets, comets, and other objects in the solar system, the motion of 3I Atlas was not governed by the Sun's gravitational forces. Instead, it was moving through the solar system under its own momentum, influenced by a variety of forces such as radiation pressure, the gravitational pull of nearby stars, and the interstellar medium. The interaction between 3I Atlas and the interstellar medium, composed of gas, dust, and radiation, likely played a role in shaping the object's trajectory and speed, further complicating our understanding of how objects in interstellar space behave. Another key aspect of 3I Atlas's passage through the solar system is its composition. Unlike typical comets, which are composed largely of volatile materials like water ice, 3I Atlas appears to be made up of solid rock or metal. The lack of a visible tail or coma further suggests that the object does not contain significant amounts of ice or gas. This is in contrast to many of the comets observed within the solar system, which exhibit dramatic changes in their appearance as they approach the Sun, often forming bright tails as gas and dust are released from their surfaces. The fact that 3I Atlas lacks these typical features raises important questions about the diversity of materials that make up objects in different star systems. Its solid composition suggests that objects in other star systems may not all be composed of ice and gas, but could instead be made of more durable rock-like materials. The discovery of 3I Atlas has also prompted a re-evaluation of how interstellar objects form and evolve. In the case of comets and asteroids within the solar system, we have a relatively good understanding of their origins. These objects are thought to have formed from the remnants of the early solar nebula, the cloud of gas and dust that surrounded the young sun. However, the formation of interstellar objects like 3I Atlas is much less well understood. The object's solid composition suggests that it may have formed in a different environment, one where conditions were not conducive to the formation of volatile compounds, like water ice. This has led scientists to speculate that the processes governing the formation of interstellar objects may be fundamentally different from those that govern the formation of objects within star systems. By studying 3I Atlas and other interstellar visitors, astronomers may gain new insights into the processes that govern the formation of planets, asteroids, and other celestial bodies in other star systems. The study of 3I Atlas has also brought renewed attention to the concept of panspermia, the hypothesis that life or its building blocks could be transported across the galaxy by objects like 3I Atlas. While there is no direct evidence to suggest that 3I Atlas carries organic material or microbial life, its passage through the solar system has spurred scientists to consider the possibility that interstellar objects could serve as vehicles for the spread of life across the galaxy. If objects like 3I Atlas are capable of carrying organic molecules, they could play a role in the distribution of life's building blocks between star systems. This idea is still speculative, but the discovery of 3I Atlas has revived interest in the concept of panspermia and has opened up new avenues of research into the potential for life to spread across the galaxy. As scientists continue to study 3I Atlas, they will gain a deeper understanding of the forces that govern the movement of interstellar objects. The object's passage through the solar system has already provided valuable data on the behavior of objects in interstellar space, and its study will continue to inform our understanding of the larger processes that shape the galaxy. Future discoveries of similar objects will build on the knowledge gained from studying 3I Atlas, providing new insights into the dynamics of interstellar space and the objects that travel through it. The study of these objects will also play a crucial role in the development of future space exploration technologies. As we look toward the possibility of interstellar travel, understanding how objects like 3I Atlas move through space will help us design spacecraft that can navigate the vast distances between stars. In conclusion, the discovery of 3I Atlas has already had a profound impact on our understanding of interstellar space and the objects that inhabit it. The object's unexpected passage through the solar system has challenged many of our assumptions about the nature of space and the forces that shape celestial bodies. It has also sparked a wave of new questions about the formation and behavior of interstellar objects, the potential for life to spread across the galaxy, and the future of space exploration. The study of 3I Atlas is just the beginning, and as we continue to observe and learn from interstellar objects, we will continue to push the boundaries of what we know about the universe and our place in it. This object, though a brief visitor in our solar neighborhood, has already helped shape the future of astronomy, and its legacy will live on in the discoveries it has inspired. As the discovery of 3I Atlas continues to inform our understanding of interstellar space, it also highlights the need for further advancements in space exploration and technology. The study of objects that travel between stars presents unique challenges requiring both innovative observation techniques and new theoretical models. to fully understand their behavior. The unexpected nature of 3I Atlas's passage through the solar system has brought attention to the limitations of current astronomical instruments and the need for more sensitive detection systems. Despite its detection by the Atlas survey, the short time frame during which the object was visible from Earth demonstrates just how fleeting these interstellar visitors can be. As interstellar objects become a more central focus of astronomical research, improvements in detection and observation technologies will be essential to monitor objects that may otherwise go unnoticed. Future interstellar discoveries like 3I Atlas will likely require the development of new techniques to detect objects much further from the solar system than is currently possible. In particular, improvements in infrared and radio wave detection could help astronomers observe objects that are not visible in visible light, which is the primary method of observing celestial bodies today. The interstellar medium, composed of low-density gas and dust, can be challenging to study, and the ability to detect and track objects moving through this space will be crucial for understanding their interactions with the environment and their trajectories through the galaxy. While 3I Atlas's detection was a major achievement, its relatively small size and lack of a visible tail highlight the importance of developing specialized instruments for tracking objects that do not exhibit the expected features of typical solar system bodies. In addition to the need for better observational tools, the study of 3I Atlas has underscored the importance of refining our models of interstellar object dynamics. The unexpected acceleration observed in 3I Atlas has challenged many of the assumptions that astronomers use to describe the movement of objects in space. Traditionally, objects like comets and asteroids are assumed to be influenced primarily by gravitational forces, with occasional deviations caused by radiation pressure or sublimation. However, 3I Atlas's behavior has shown that interstellar objects may experience a more complex set of forces than those observed in typical solar system bodies. The study of the object's motion is prompting astronomers to rethink the factors that contribute to the dynamics of interstellar objects, leading to new models that better account for the influence of both the solar system's gravity and the interstellar medium. Moreover, the discovery of 3I Atlas has opened new questions about the fundamental nature of interstellar space. The object's passage through the solar system has shown that interstellar objects are not isolated anomalies, but part of the broader cosmic environment. The way in which 3I Atlas moved through space, its interactions with the sun's radiation, the interstellar medium, and the gravitational forces of nearby stars raises important questions about the structure of the galaxy and how objects move between stars. The behavior of 3I Atlas could have implications for the formation and distribution of objects in interstellar space, shedding light on how matter moves across vast distances between stars. By studying how 3I Atlas interacts with its environment, we can gain a deeper understanding of the processes that govern the distribution of objects and materials throughout the galaxy. Another area where 3I Atlas is pushing the boundaries of our understanding is in the composition of interstellar objects. While 3I Atlas was not composed of volatile materials like typical comets, it may provide important clues about the material makeup of other star systems. The fact that the object appears to be made primarily of solid rock or metal suggests that it may have originated in a star system where conditions were more similar to the inner regions of the solar system, where rocky planets and asteroids form. This stands in contrast to the icy bodies typically found in the outer reaches of the solar system. By studying the composition of 3I Atlas and comparing it with other known interstellar objects, astronomers may be able to develop new models for the formation of planetary bodies in different star systems. It is possible that many interstellar objects share a similar composition, providing insight into the nature of planets and other celestial bodies that exist outside our own star system. 3I Atlas's solid composition, combined with its high velocity and unpredictable trajectory, has raised additional questions about the resilience of interstellar objects. Objects that travel through interstellar space are subjected to a variety of environmental factors, including cosmic radiation and the interstellar medium. These forces can cause objects to erode over time, stripping away material from their surfaces, or even causing them to break apart. Yet 3I Atlas managed to survive its long journey through interstellar space without significant alteration. This suggests that some interstellar objects may be much more resilient than previously thought, possibly due to their composition or the specific conditions in their home star systems. By studying the durability of 3I Atlas, scientists can better understand the forces that shape interstellar objects over long periods and the extent to which they can withstand the harsh conditions of space. One of the key questions surrounding 3I Atlas is whether objects like it could play a role in the spread of life across the galaxy. The idea of panspermia, which suggests that life's building blocks could be transported across space on objects like comets or asteroids, has been proposed as a potential mechanism for the spread of life between star systems. While 3I Atlas has not shown evidence of carrying life-related molecules, its passage through the solar system has raised important questions about the potential for interstellar objects to deliver organic material between stars. If interstellar objects are capable of carrying the basic components for life, this could have significant implications for the search for life beyond Earth. Studying 3I Atlas and other interstellar objects could provide new insight into the conditions under which life might spread across the galaxy, whether life is more widespread than we currently think, and whether Earth could have been seeded by material from other star systems. Beyond these scientific questions, 3I Atlas's passage through the solar system has also inspired new thinking about the future of space exploration. While sending spacecraft to other stars is still a distant goal, the study of interstellar objects is helping to shape the future of space travel. By understanding how objects like 3I Atlas behave in interstellar space, scientists can gain valuable insights into the challenges of interstellar travel. This includes refining our understanding of the forces that act on spacecraft as they travel through space, as well as improving the technology needed to detect and track objects across vast distances. As humanity works toward the possibility of interstellar missions, the lessons learned from studying 3I Atlas will play an important role in developing the tools, technologies, and strategies needed to navigate the vast expanse between the stars. In conclusion, the discovery of 3I Atlas has significantly advanced our understanding of interstellar objects and the forces that govern their motion. The study of this object has raised fundamental questions about the nature of interstellar space, the composition of objects that travel between stars, and the potential for life to be spread across the galaxy. It has also illuminated the complexities of space exploration, pushing us to rethink our understanding of the forces that shape the universe and our place within it. As more interstellar objects are discovered and studied, we will continue to build upon the insights gained from 3I Atlas, shaping the future of astronomy and space exploration for generations to come. As 3I Atlas moves beyond the solar system, its legacy as the first confirmed interstellar object to pass through our space continues to resonate across the field of astronomy. The data gathered from its brief visit has not only answered some of the long-standing questions about interstellar objects, but has also raised a host of new questions that scientists are eager to explore. The study of 3I Atlas has proven to be more than just a singular event. It has opened the door to a new field of study, one that involves the tracking, observation, and analysis of objects from other star systems. This new frontier of astronomical exploration will undoubtedly lead to even more discoveries, broadening our understanding of the universe in ways we have yet to fully appreciate. The discovery of 3I Atlas has shown that interstellar objects are not just rare anomalies, but rather an integral part of the cosmic environment. The object's unexpected arrival in the solar system challenges the notion that the solar system exists in isolation. Instead, it suggests that the universe is much more interconnected than we once thought, with objects traveling freely between stars. If 3I Atlas is any indication, interstellar objects could be a regular phenomenon in space-crossing star systems and interacting with other celestial bodies in ways that we are only beginning to understand. This realization has profound implications for our understanding of galactic dynamics and the broader structure of the universe. It suggests that the universe is not just a collection of isolated star systems, but a dynamic, interconnected network of objects moving freely through the vast expanse of space. As astronomers look to the future, it is likely that more interstellar objects will be discovered. The development of more advanced telescopes and detection methods will improve our ability to spot these objects as they pass through the solar system, increasing the frequency with which we can study them. While 3I Atlas was detected thanks to the Atlas survey, the object's brief appearance in the solar system underscores the need for more sensitive detection systems to monitor interstellar space. Interstellar objects are often faint and difficult to spot, and they move rapidly across vast distances. To fully understand their behavior and origins, astronomers will need to refine their observation techniques and invest in better technology to track these objects as they pass through the solar system. The study of 3I Atlas also raises important questions about the dynamics of interstellar space itself. While we often think of space as a vacuum, interstellar space is not truly empty. It is filled with a sparse but pervasive mixture of gas, dust, and radiation, which can influence the motion of objects traveling through it. The fact that 3I Atlas has managed to travel such vast distances without significant alteration suggests that some interstellar objects are more resilient than we might have expected. However, studying 3I Atlas's passage through the solar system provides valuable insight into the forces at work in interstellar space and how these forces can affect the motion and behavior of objects moving through it. In particular, understanding how objects like 3I Atlas interact with the interstellar medium will be key to refining our models of interstellar dynamics. One of the most important lessons from studying 3I Atlas is that these objects are not entirely unpredictable. Although 3I Atlas's trajectory was unique, it followed a predictable path based on the laws of physics. Its motion was influenced by a combination of gravitational forces from the Sun and the interstellar medium, as well as non-gravitational forces such as radiation pressure. While the object's path through the solar system was not completely straightforward, it is clear that interstellar objects follow principles that can be understood and modeled. This opens up the possibility of predicting the movement of future interstellar visitors with increasing precision. The more we learn about how objects like 3I Atlas move through space, the better equipped we will be to predict the paths of other interstellar objects that may enter our region of space in the future. In addition to its impact on interstellar space studies, 3I Atlas has also spurred renewed interest in the search for extraterrestrial life. The idea of panspermia, or the possibility that life or its building blocks could be spread across the galaxy by objects like comets or asteroids, has gained traction in recent years. While there is no evidence to suggest that 3I Atlas carries life-related molecules, its passage through the solar system has led scientists to consider the role that interstellar objects might play in the distribution of life across the universe. The discovery of interstellar objects like 3I Atlas has shifted the focus of the search for extraterrestrial life, highlighting the possibility that life's building blocks could travel between star systems, potentially seeding life on distant planets. The study of 3I Atlas has also provided valuable information about the conditions that prevail in other star systems. Observations suggest that the object is composed primarily of solid rock or metal rather than ice or gas. This has important implications for understanding the material composition of objects in other star systems and provides a glimpse into the types of planets, asteroids, and comets that may exist outside the solar system. By studying the composition of 3I Atlas, scientists can develop new models for the formation and evolution of planetary systems in other parts of the galaxy. The object's solid structure suggests that many interstellar objects may share similar compositions, offering clues about the materials that exist in other star systems. The passage of 3I Atlas also raises important questions about the future of space exploration. As humanity looks toward sending spacecraft to other stars, understanding the behavior of interstellar objects is crucial. 3I Atlas's high velocity and its interaction with the interstellar medium offer valuable insights into the challenges of interstellar travel. The study of this object's motion and composition can help scientists design spacecraft that are better equipped to navigate the vast distances and harsh conditions of interstellar space. The lessons learned from studying 3I Atlas will be vital for the development of future technologies that can support the exploration of other star systems. In conclusion, the discovery of 3I Atlas has had a profound impact on our understanding of interstellar space and the objects that traverse it. Its passage through the solar system has opened up a new field of research, one that is focused on the study of objects from beyond our star system. The lessons learned from 3I Atlas are far-reaching, with implications for our understanding of galactic dynamics, the formation of interstellar objects, and the potential for life to be spread across the galaxy. As we continue to study 3I Atlas and other interstellar objects, we will expand our knowledge of the universe and refine our models of space. The discovery of 3I Atlas represents just the beginning of a new era in astronomy, one that will shape the future of scientific exploration for generations to come. As we reflect on the passing of 3I Atlas through the solar system, it becomes increasingly clear that the object's journey has offered far more than just an intriguing anomaly. It has become a critical turning point in the study of objects from interstellar space, expanding our understanding of both the universe and the techniques we use to explore it. The sheer scale of the implications is profound, as the study of 3I Atlas has far-reaching consequences, not only for astronomy and space exploration, but also for our broader view of the cosmos. In many ways, the discovery of this interstellar visitor represents the beginning of a new era in scientific research, one where objects from outside our star system become key components in unraveling the mysteries of the universe. 3I Atlas's passage through the solar system has reaffirmed the idea that space is not as empty or isolated as it may seem. This object, which arrived from another star system, demonstrates the interconnected nature of the galaxy. The detection of such objects proves that the movement of material between star systems is not just theoretical, but an active and ongoing process. It suggests that there is an exchange of material energy and possibly even life-related molecules throughout the galaxy. As 3I Atlas moves farther from the Sun, it is already contributing to a larger understanding of the mechanisms at play within our galaxy. The study of its velocity, trajectory, and behavior provides vital clues to how objects travel across vast distances, interact with their environments, and move between the stars. One of the key lessons from 3I Atlas's journey is the realization that the solar system is not an isolated island in space. While for many years, the Sun and its planets were seen as somewhat detached from the broader cosmic community, this object has shown that our solar system is but one part of a dynamic, interconnected web of star systems. Objects like 3I Atlas traveling from distant stars remind us that the universe is a constantly shifting, ever-changing network of objects in motion. It is a system in which even the smallest objects like asteroids or comets can be influenced by the gravitational forces and radiation of stars far beyond our own. This understanding challenges the notion of the solar system as a self-contained system and underscores the interconnectedness of stars' galaxies and the objects that populate them. 3I Atlas also serves as a reminder of the transient nature of objects in the universe. While objects that belong to the solar system are bound by the Sun's gravity, interstellar objects are free agents moving through space on paths dictated by the forces they encounter. Unlike comets, asteroids, or planets which follow predictable orbits or trajectories, interstellar objects like 3I Atlas are transient visitors passing through our space for only a brief moment in the grand timeline of the universe. The fact that 3I Atlas was detected during its brief stay in the solar system serves as both a reminder of the fleeting nature of such encounters and an illustration of how little we know about the objects that pass through our space. These objects come from far beyond our star system, from the unknown reaches of interstellar space, and their passage can offer us a unique, if fleeting, opportunity to study the processes at work in other parts of the galaxy. As we look to the future, the study of 3I Atlas presents the exciting possibility of discovering more interstellar objects. The lessons learned from its passage through the solar system are paving the way for future research and exploration. As technology continues to improve, astronomers will have better tools for detecting objects that travel through interstellar space, even if they are faint or distant. The detection of 3I Atlas was only possible because of the advanced observational methods used by the Atlas survey. But future advances in space telescopes and detection systems will likely make it easier to spot such objects before they enter the solar system. The ability to detect interstellar objects early on will give scientists more time to study them and gain valuable insights into the forces that shape the motion of objects across the galaxy. One of the primary challenges that astronomers face is understanding the exact nature of interstellar space itself. Interstellar objects like 3I Atlas travel through an environment filled with gas dust and radiation that is vastly different from the conditions within the solar system. These objects are not only affected by gravitational forces, but also by the interstellar medium, a sparse, diffuse collection of particles that fills the space between stars. This medium can exert subtle forces on objects as they move through it, altering their speed, trajectory, and even their composition. The interaction between 3I Atlas and the interstellar medium during its passage through the solar system is still not fully understood, but it is clear that the object's motion was influenced by these forces. Future studies will be focused on better understanding the dynamics of interstellar space and how objects like 3I Atlas are shaped by the medium they travel through. The discovery of 3I Atlas also opens up the possibility of discovering more objects that share similar characteristics. As scientists study this object and refine their detection methods, the likelihood of finding more interstellar visitors increases. Whether these objects are similar in composition to 3I Atlas or vastly different, the study of these objects will help scientists understand the broader processes at work in the galaxy. If 3I Atlas is typical of the types of objects that exist in other star systems, it suggests that the galaxy is populated by a wide variety of solid bodies, some composed of metal and rock, others potentially carrying volatile materials like ice. Each interstellar object presents a unique opportunity to learn more about the conditions that prevail in other star systems and how these conditions might shape the formation and evolution of planetary bodies. The fact that 3I Atlas has not shown typical cometary behavior has raised important questions about the diversity of interstellar objects. Most comets are known for their tails and bright comas caused by the release of gas and dust as they approach the Sun. But 3I Atlas, instead of releasing material from its surface, has remained relatively unchanged throughout its journey through the solar system. This may suggest that interstellar objects are made of different materials than those found in our own solar system, or that they experience different processes as they move through space. The study of 3I Atlas's composition and behavior is critical for understanding how other interstellar objects are formed and how they evolve as they travel through space. Finally, the discovery of 3I Atlas has profound implications for the future of space exploration. As humanity looks toward the stars and contemplates sending spacecraft to other star systems, the lessons learned from 3I Atlas will be crucial. The high velocity of the object coupled with the forces it encountered during its passage has provided valuable insight into the challenges of interstellar travel. The more we learn about how objects like 3I Atlas move through space and interact with their environment, the better prepared we will be for future space missions. This knowledge will help shape the design of spacecraft capable of traveling vast distances across the galaxy, enabling humanity to explore the stars in ways that were once thought impossible. In conclusion, 3I Atlas has not only provided valuable data about interstellar objects, but has also served as a catalyst for rethinking the dynamics of space and the way objects travel between stars. Its passage through the solar system has opened new avenues of research, challenging many of the assumptions we had about space, the forces that govern it, and the objects that inhabit it. As the study of 3I Atlas continues and more interstellar objects are discovered, we will gain a deeper understanding of the vast and interconnected universe we inhabit, moving closer to a future where the mysteries of interstellar space can be fully explored. As we conclude the exploration of 3I Atlas's passage through the solar system, its legacy as the first confirmed interstellar object observed in real time continues to shape our understanding of the universe. The unique data gleaned from this brief encounter has already enriched multiple fields of space science, revealing new perspectives on the way objects behave in interstellar space, how they interact with their environments, and how they contribute to the broader cosmic ecosystem. But as with any great scientific breakthrough, the discovery of 3I Atlas raises as many questions as it answers, compelling researchers to refine their methods and expand their models in ways that may fundamentally alter our understanding of space and our place within it. The study of 3I Atlas has shown that objects from beyond the solar system are more common than we once thought. The discovery of 3I Atlas was not an isolated event, but rather the beginning of a new era in astronomy, one where interstellar objects are expected to play a central role in future research. While 3I Atlas was the first confirmed interstellar visitor, astronomers now suspect that many other such objects have passed through the solar system undetected due to the limitations of current observational tools. The challenge now lies in improving our ability to detect these objects early enough to study them in detail, expanding our understanding of the forces at play in interstellar space. This shift in focus toward interstellar objects reflects the evolving nature of astronomical exploration. For years, the study of celestial bodies was largely confined to objects within the solar system: planets, moons, asteroids, and comets. But the detection of 3I Atlas has forced a reimagining of the boundaries of our study. No longer is our solar neighborhood isolated from the rest of the galaxy. Rather, it is part of a vast cosmic network in which objects travel freely between stars. This realization has profound implications for how we understand the movement of matter, the formation of star systems, and even the potential for life to be spread across the galaxy. The idea that interstellar objects could carry organic molecules or life's building blocks between stars is a thrilling possibility that opens up new avenues of inquiry about the origins of life and the conditions necessary for its existence. As we learn more about objects like 3I Atlas, we also begin to realize how much remains to be understood about the broader dynamics of interstellar space. 3I Atlas's trajectory through the solar system has already challenged many of our assumptions about the movement of objects in space. Unlike comets and asteroids, which are bound by the gravity of the Sun, 3I Atlas's hyperbolic path suggests that it is not subject to the same gravitational constraints. Instead, it is a free agent moving through space on a trajectory determined by its own momentum and the forces it encounters. This raises questions about how objects from other star systems interact with the solar system, and what role the Sun's gravity plays in shaping the movement of objects that are not gravitationally bound to it. The study of 3I Atlas also emphasizes the need for more sophisticated models of interstellar object dynamics. The object's unexpected acceleration, which could not be fully explained by the Sun's gravity alone, suggests that other forces, such as radiation pressure or sublimation, are at play. The possibility of non-gravitational forces acting on interstellar objects is a critical area of research, and the study of 3I Atlas has opened up new lines of inquiry into the nature of these forces. While gravitational slingshot effects are well understood for solar system objects, the dynamics of interstellar objects are more complex and require further study to fully comprehend. In addition to its role in shaping our understanding of space, 3I Atlas's passage has prompted a reevaluation of how we approach space exploration. The study of objects from beyond the solar system offers new insights into the potential for future interstellar missions. While human exploration of other star systems remains a distant goal, the study of interstellar objects like 3I Atlas provides valuable data that can inform the design of future spacecraft. If we are to travel to other stars, we must first understand how objects move through the vast expanse of space, what challenges spacecraft will face, and how they can navigate the complex forces at work in interstellar space. The lessons learned from studying 3I Atlas will guide the next generation of space explorers and help us better prepare for the challenges of interstellar travel. The impact of 3I Atlas on the search for extraterrestrial life cannot be overstated. The idea that life could travel between stars on objects like comets or asteroids known as panspermia has long been a subject of speculation. While there is no evidence that 3I Atlas contains life, its passage through the solar system raises important questions about the potential for life to spread across the galaxy. The idea that interstellar objects could carry the building blocks of life between star systems is a tantalizing possibility, one that has profound implications for the search for life beyond Earth. The discovery of 3I Atlas has sparked new interest in the potential for panspermia, and future studies of interstellar objects will likely focus on whether these objects could be carriers of organic material or even microbial life. The study of 3I Atlas also opens up exciting possibilities for understanding the nature of interstellar space itself. The object's passage through the solar system has shown that objects from outside the solar system are not isolated from their surroundings, but are instead part of a much larger cosmic system. The interstellar medium, the region of space between stars, is not a vacuum, but rather a sparse collection of gas, dust, and radiation. As 3I Atlas passed through this medium, it was subjected to forces that we are only beginning to understand. The interaction between interstellar objects and the interstellar medium is an important area of study, and the data collected from 3I Atlas's passage will provide valuable insights into how these objects move through interstellar space and interact with their environment. While the study of 3I Atlas has already yielded many important insights, the journey is far from over. The object's brief stay in the solar system has provided only a snapshot of its behavior, and as it continues on its path through interstellar space, new discoveries will undoubtedly emerge. Future observations of interstellar objects, whether they be 3I, Atlas, or other objects yet to be discovered, will continue to expand our knowledge of the forces at work in the universe. As technology improves and our ability to detect and track these objects increases, we will gain a deeper understanding of the galactic environment and the role that interstellar objects play in shaping the universe. The study of 3I Atlas represents just the beginning of a new era in space exploration and astronomy. As more interstellar objects are discovered and studied, we will continue to refine our models of space and the dynamics of objects that travel between stars. These objects are not just fleeting visitors. They are windows into the broader processes that govern the universe, offering a glimpse into the complex forces that shape the behavior of matter on a galactic scale. The legacy of 3I Atlas will continue to inspire scientific inquiry and space exploration for generations to come, and its passage through the solar system will stand as a milestone in our journey to understand the vast and interconnected cosmos.